Have your transformation test tomorrow. Remember, I'm not here after school today, so whatever questions you have to get them through this period. All right. This is all on Classroom. As you remember, this is all on Classroom. No need to copy it down. A couple things. Reflections, just make sure, I'm not going to go over them, but make sure you guys know your y equals x versus reflection through y equals negative x. All right, there's 2 rules for that, so make sure we know both rules. 2 constructions, both could be on, one could be on, the other could not be, but make sure you know how to find the line of reflection. That was on your quiz, so look back at that. And then how to dilate given a scale factor of either 2 or 1/2. Both are in at the end of your review packet. If you weren't here on Friday, make sure you eliminate questions 18 and 19. They have nothing to do with what's on there. Okay. And the only other thing, just watch out. Make sure you know the difference between reflecting through a point versus dilating a point. Okay, make sure you know the difference there. All right, make sure we know the difference. Let me just go over it real quickly, actually, instead of talking about it. All right, I'm going to give, this is point A. Let's start with reflecting through a point. Reflecting through a point. Let's say I want to reflect through point X up here. Okay, reflecting through point X. How do I reflect A? Now remember, when I say reflect, it's got to be on the other side of the point. Okay, when we say reflect, it's got to be on the other side of the line. In this case, on the other side of the point. Now, how do I get on the other side of the point? I use slope. Up 1, 2, 3, 4, 5 over 2. 1, 2, 3, 4, 5 over 2. So that's A prime. That's reflecting through a point. Everybody good there before I change it up? Now let's say I'm going to dilate by 2. Scale factor of 2 here. I want to dilate A, but X is my center. Is A going to be on the other side when I dilate? No, it's going to be further away, right? On the same side, further away. So now I start with X and go, all right, over 2, down 5. And now what do I do again? Over 2, down 1, 2, 3, 4, 5. Or if it's 1/2, I cut it in half and it's still there. Reflect, you're on the other side. Dilate, you're on the same side, either getting closer or further away from your point. Everyone good on the difference? I just want to make sure we're good because it's almost the same thing, but one ends up on the other side, one ends up on the same side. Is there anything up here before I let you go to work that you want to talk about? Invariant points, points that don't move, they stay right where they are. Orientation, we're good. Opposite versus same. Because I'm sure, I just didn't write these up there just to make it longer. Everything's going to be on there. How do we read these right here? How do these perform? Read whatever's right to left. Remember, right to left. So rotate, then reflect in that case. If the center of dilation's on the line, does the line change? No, it remains the same line. If the point's not on, they stay parallel. Nothing at all. All right, let's get to it. Again, when I'm walking around, seeing what you're doing, I should only be hearing about transformation stuff, not about other classes or other drama outside of school. All right, let's get going. Come on, use your time here. You can work with other people in your group, but please don't move around. If you need anything, call me.